All right, can you hear me? Thank you everybody for coming back to the office and continuing our great hackathon. It's been a long 24 hours and we're still not done. It's time to see what is it that you got done. The great ideas, the great projects, and we're so excited to see them all. But now it's time to begin, and we're starting with our great Tram Jam project. So, welcome to the stage.
Thank you so much, Elisa. Okay, so the Tram Jam team consists actually of 4 teams. So we will go through the general idea first, and then each kind of sub-team can present their results. Okay, so the background behind the Tram Jam was that we wanted to make it possible to estimate how full a tram is just based on data we get from the HSL APIs. So we don't have actually like any passenger counters or anything available there, so we had to use other data. So for this, we have this service where you can query a tram trip with its ID, and you will get back a number between 0 and infinity, where 0 means that the tram is completely empty, 1 means that it's as full as on average, and etc. So for example, a number 2 means that it's double full as average, and half means that it's half full as average. Pretty simple. So this was kind of the premise of the project. We had this system working, and then we wanted to build some like auxiliary systems around it, like a map where you can see all the trams in the Helsinki area and how congested they are. So we had the Sporat.fi as an inspiration. And then we also had a great data team who found some interesting insights about the data we have collected this far. But yeah, as I said, we divided into 4 teams: data, then a UX design team. We had 1 team optimizing the existing backend, and then we had the team building the front end with the map. So without further ado, I would like to invite the data team to present their findings and results.
Thank you. So we are the data team, and already you know that our data set is the Tram Jam. So we are excited to make kind of history out of the data. So basically our data set, it was consisted of about 2.3 million observations, and we found like there was about 248 tram stations with 7 features. Like we had kind of name of the stoppage ID, and trip ID, geolocation, and the time of door closing and opening. So basically it was the real time time series data from 20th of August 2019 till end of September 2019. So here in this visualization, we can see the 248 tram stations in Helsinki region.
Well, we have just used the stop ID. Instead of a stop ID, we could have used the location name. So we can do that. Yeah, this one is with the stop name.
So yeah, this one is with the stop name. So basically, there is one thing to mention, like before going to analyze the data set, we were thinking like, okay, whatever the data set is, maybe we will get the results, the busiest station somewhere near Rautatientori or nearby. But after analyzing this data, we found the most busiest place of the tram station is Urheilutalo. And we have shown the size of the station based on the busyness. So here is the simple picture. We can see them with their name, and it's pretty easy to see. So we can see that Urheilutalo is the first one, and number something like the Rautatiet Asema is number 4th, and Opera is number 6th. So actually, we also tried to find out the average time of the average time of what can I say? Like how long each tram was stopped at its station. Then we found it was like from the data set that it was about 90 seconds. But also we have been observed that basically the data set might have some like bad recordings. Like I was also talking with Apo, and he said maybe the sensor is the one problem, and that's why maybe it was showing basically the Alexandrin Katu and natural resource stoppage, and one is Tolon Halli. It's showing like more than 6 minutes the tram was there. So overall, this kind of length of the stoppage affected the whole average calculation, and that's why we got like the average estimation is 1.55 minutes. So we also analyzed one tram station's calculation, and we found like, okay, there was something 10 to 36 seconds the average time of stoppage of each tram. Okay, this is basically the location of the 10th highest or busyness the places. So we found somewhere. We can see here this. I think this is Opera and something Rautatientori and Hakaniemi. So basically, these are the places in Helsinki region we found the busiest areas. Okay, that was our findings. Thank you.
So I'm the UX team, all of us, one here. And I was in charge of sort of visualizing what the data would look like to the end user. There's the HSL app is already in use, and this is just some added layer and functionality on top of it. So there's this view where you can personalize what you want to see in your app. Information about the means of transport you are using. So you can choose the line or the area or a subject where you travel. And this is a picture, not so much needed, but it shows what you can choose. And this is the current view already. It's just a bit modified, so currently it's only like gray spots that tell that there's information about that certain line or a route. But in this, there's these traffic light thingies in use. So if it's yellow, then it's moderately full, and if it's red, it's really full, and there could be possibilities that it's so full that you can't get in, and so on. And it could also produce an alternative route or a vehicle that you could take if you decide that it's not convenient for you to choose a tram that is really full and you want to sit down, for example. And then a more detailed view, when you click into the route number, you can see the stops on the map and how the stops are, if possibly you would like to change to a different stop or something like that. And in this, my idea was that could also offer you more alternative ways of transport, such as walking or taking a bike, and even a link to the weather, so you can decide on what you want to do. Do you want to wait for the next tram, or take your chance, or start walking? Yeah, that was my part.
All right, so part of our team worked on optimizing the congestion rate calculation. So I was working with this with Asia in the back. Okay, so some background again. So this congestion rate calculation is totally custom. It's not provided by HSL in any way. It basically works that it collects all the door open and door close events from the HSL real-time API to a MySQL database, and then it calculates based on that how long the doors were open at a given station, and gives the congestion rate based on that number. So the problem is that we have over 2 million rows at this point in the database. So we had the problem that the request to calculate the congestion rate for one trip took over 1 minute initially yesterday. And we were able to get it down to 200 milliseconds in the end. So quite a big reduction. We had basically three big optimizations we made. One was that we added a new index to the database. So because it needs to sort those stop times it gets from the HSL real-time API, it needs to sort those in time order. So we added a new index there to make sure that that happens fast. So it's able to find the matching rows fast. That was about 50% increase. So at this point we had the request at 30 seconds. One was that we optimized the JavaScript. So kind of found a hack how to filter out the duplicate stop time events we got from the HSL API. This was about, again, 35% decrease. And the last part was kind of changing the behavior that it wouldn't count the average stop time from the whole dataset, but only use data from the day before. So this way we had less rows to take into account, and yeah, it's obviously a lot faster. So after this change, we had the request time to 200 milliseconds. And that was kind of a prerequisite for the last team, so I would like to invite the map front-end team to the stage.
Yes, thank you. So our initial goal was to visualize the tram movements over the map, the real-time movement of the trams. And the second was to get the congestion rate for each tram from the backend that Apple has developed. And third was to make it easier for you to understand, color code the tram based on its congestion rate.
Based on this requirement, we divide our team in 3 tasks. So the first task is to make the front end. So that is what I care of. I make the front end with React, Leaflet, OpenStreetMap, and I also care about to connect another part together.
Okay, and my part is connect the front end with the back end to get the congestion rate for each tram, and also with the just remind about the color. So it's yellow is 0 to less than 0.5, 0.5 to 1.5 mean yellow, which is like half full or half empty. And the red one, of course, is from more than above 1.5. So either you squeeze in or choose another tram.
Yeah, and for the real-time location, we use the HSL provided high-frequency positioning API, and we got the real-time longitude and latitude of all of the trams inside the Helsinki region, and we use that to get the congestion from the backend.
So let's go to the demo. So please take like 30 seconds to open the website. We have done is here's the website link on your mobile or your laptop. Please do it. Yes, and also I will open it now. Yes, so you can see.
So as you can see, it takes some time to show up. So now we have color coded all the times in real time so that we can see the congestion rate of each tram. So red meaning it's like heavily congested, and the green means it's not, and yellow is the average. So now we can see all the trams inside the Helsinki region based on this congestion. How is it? And when you click on it, we can see the tram number and also the congestion rate that is sent back from the back end. So further improvements that we were wanting to do, but because of the time limitation we couldn't, was to show the tram direction on its marker so that we know which direction it's heading. And the second was to filter the trams among all the trams. Like if I want to see the tram number 2, then it filters out only the tram number 2. And to add more, we were also thinking about like based on your location, it shows all the incoming trams towards you, so that you know like which tram you have to take. So this was our whole project, our hackathon. So if you have any questions, this is the time.
Thank you so much.
Hello, everybody. We are here to present Brokebike Station, the Brokebike Station project. We have 3 different teams, and these 3 different teams work on a different project, on a different idea. And now we are here. The first team is the bike team. So now I give to them the voice.
Thank you. Hello, everybody. I like cycling, so because of that, I like Helsinki City Bike. What? No, I'm just talking about the project. So it is really annoying when you go to bike station and there is only one bike and it is broken. So you have to find the nearest one, and when you check the nearest one, there is no bike, and you have to estimate how many minutes you're gonna wait there. So with this project we are solving that problem. We implemented mobile application, and with this mobile application we can estimate how many minutes you can wait if there is no bike in the station, and we can also recommend if there is only one bike or 2 bikes. They might be broken, so we can suggest you need to go to nearest bike station. So in this application, we used Flutter, so we can easily deploy our application in iOS or Android environment. And for maps, I'm using Google Maps because for me it is easy. I can run a demo. For example, yeah, there is no bike here, and when you click, it will say there will be more bikes in 5 minutes. So you don't need, if you are close to here, you don't need to go anywhere. You can wait there 5 minutes. And for the estimation, we are fetching your current location, and we are fetching also weather information because for prediction, we are using merging this weather information and bike station data. So we are estimating the future estimation according to weather data. So if it is rainy, for example, there will be more bikes on the station. If it is sunny, everybody will use bikes. So probably there will be less bikes in station. And when we click this one bike station, for example, it says it is broken and don't go there because it is broken, you can't use that bike. And behind this UI, there is a big, great data science, and I would like to invite my data science team.
Hi everyone. We are like Bike Helsinki group, and my colleague already mentioned some of the goals we are trying to accomplish in this project. So since we were open data, so we have some goals. So like the problem statement, like my colleague mentioned earlier, like it will be nice to have some prediction, like how many bikes will be there in certain stations after some times, or to predict even if there is bike, like what's the possibility if that bike is working or if that bike is broken, and if there is no bike, like after how many minutes there will be another bike. So it would be really cool to have that that prediction. So we're working on that. We come with some baseline solution in some cases, and in some cases like we could not with some certain problems. So basically we use for this modeling these problems, we used some bike rental data from the year of 2017, and that data set was quite high. The dimension was like it consisted of like almost 8 million rows and 9 columns, and it was time series data, like how that means like there were some variables whose value will change with time. So this is just some snips of the data, and the data actually consists of like the name of the place and its location, latitude and longitude, is X and Y, and the bikes available in that station, and the space available, allowed drop-off, and the is it real-time data or not, and at what time that data has been collected. You can see that with certain interval. Only here we can see only one interval, but it's in different location, but it's actually the data is collected at different interval. So to use with this data to model the problem we earlier mentioned, we did certain data wrangling with that data, like dropping NA values, or there might be different reasons that there might be NA values in data. Either the data was not actually collected, or there might be, in fact, there was no data to collect. And earlier we see that the interval were quite, we could not actually find like at what actual interval the data has been collected. So we then later like modeled that data with the window size of 15 minutes. So in every 15 minutes, like what is a median available number of bikes in every station. So when we model, like for example, here we can see like in this Alberten Katu, then we with the window size of 15 minutes, then we see that in the median number of bikes available will be like 27, like at 12 o'clock at night. At 12 past 15, there was 27 bikes, and maybe at 1 o'clock there was the median number of bikes available were like 26. So we take this window size of 15 minutes. So then we try to visualize the data, like if we can find some interesting pattern in that data, we did some explanatory data analysis. Since that is 1 year data, but we took for a couple of days data to see. For example, here we took the data for like on the day of 4th of September. Then we can like and see the number of bikes available at different time in the day. So here we can like clearly see like when during the time you can see like between 9 and 12, there are like almost like 0 bikes available in the station in that place. But if you see at the night time, like at 12 o'clock at midnight, or when it's getting evening, then there's the number of bikes available in that station is increasing. Or one possibility is that the time period between 9 o'clock or 12 o'clock or around that time is the time when there is more movement of the people, like people going to office, it's the daytime, and that's why maybe almost all the bikes has been used, and when it's getting the evening or at the night, that there is less flow of the people, less movement of the people, and there might be, because of that, there is more bike available in the station. So we try to see this pattern with some more other days, and we see the similar pattern with some other in other days also in the same place. See, like here also, like when it's like the daytime or the morning time, the number of bikes available is really low. But when it's evening or nighttime, the number of bikes available in that station is quite high. So now we can go to this predictive modeling of our data. Now we'll try to model that how many bike might be in that station after some time, like future prediction of the bike. Like if I want to go to a certain station and I want to know like how many bikes will be there after a certain period of time. So in this case we use random forest model, and the feature we choose to model that data is like the station, the place name, and the number of bikes available at that moment. And as a true value, we took as a time-shifted value. And obviously, not all the features in that data are like numerical data. Like for example, the name of the place is not numerical. That is categorical data. So we try to use this one-hot encoding to model that categorical data. As a result, then actually in our data set there was 151 places. So when we one-hot encoded that, then our number of features increased to like 152 data. What result we got with this random forest model is with the mean absolute error of 0.62. Like what actually means is like, you can explain that.
So, yeah. That means like in a time frame, if we have 3 bikes at a station, then like in 15 minutes there will be chances that there will be plus minus 3 bikes in that place. So the mean absolute error means so, and the value is like near to the true value because the moment of bikes in that small time frame may be very less, and that could be the reason that mean absolute error is so less.
And there are definitely many places where we can improve that modeling. Actually, we could not address other problem like after how many minutes there will be new bikes if there was no bike at all in that station. So it all basically again comes to the feature engineering, because we didn't have that much of time like in deriving some other features from that given data sets. Like for example, like after how many, if the station had 0 bike, then after how many minutes there gonna be 1 bike, then we can like use same data set, but we have to do like a bit more of feature engineering, like try to find out like at what time that station had 0 bike, and after how many minutes like there was the presence of at least 1 bike. So if you have that, if you do that feature engineering from given data set and find that and make the data set of that data and incorporating with other weather data we discussed earlier, because there is based on the weather also, it highly affects like how the people's movement. If it's like a sunny day or like nice temperature, then there are going to be more people's movement, and they're going to be like there are going to be less bike in the station. So one of the more definitive features to model will be this weather data, but we were not able to incorporate in our model at this time this weather data. I think we believe that this will be the good feature to include while modeling that model we discussed earlier. Okay, that's it. Thank you.
Hello, everybody. We are the 30-minute station, and this is like we already had 2 groups doing this kind of availability probability thing, which was kind of like so we were thinking like maybe there's something else that we could take a look at. And as the bikes are kind of like, well, they're just bike, you can ride them, and the station and the data inside is actually the more interesting part probably here, in a way. So one of the ideas was that thinking about like the length of the time when you rent a bike, which takes, well, it's 30 minutes, and after that it starts costing more in a way. So the question was like, could we be able to actually make it so that you can actually get some information on the like how far can you go with the bike with the help of the route planning that the HSL is providing, as well as some like visual information. And also on top of that, we were also like looking around and like we just took a look at this whole like what are they now offering as like what is their information on the stations right now. And it's very basic. It's like the stations like location and then the amount and how much there is available in a way. And of course like the little feature that it lets you like select like where are you, and then it shows you where you are. And based on that, we were like kind of like, okay, so maybe we could also like think about like could we be able to improve this kind of view to actually like provide something more like more interesting looking. There's more information in the stations themselves in a way, and or to show, and like maybe you might not be interested in all the possible bikes around it. Maybe you would be only interested to see the stations that have bikes in a way. Like why bother seeing the 0 ones in a way if there is nothing to see in a way. Well, here's the repository, just like everybody else I guess did with the pushing and so on. We were mostly gathered from people interested in front-end stuff, so what we like choose as a like, since the backend is kind of like provided by the open API, we decided to say, okay, well let's just focus on the front-end stuff, and we choose the React to work with in a way, and started like to figuring out like how do we display the map, how do we display the markers and so on. And it turned out quite like quite of an like learning experience in itself of like how do we get it to display and so on, and stuff like that. It was kind of interesting, and that's kind of mostly. By far, what we got actually done is we have now like 2 versions, because now we had like this kind of the point was that like how do we calculate the queries through the trip planning, and then like how can we display it so that you can actually select between the stations and then you can see the data. So well, there's some branches also, why not? So we had like 2 versions. This is the version that like lets you actually see the like stuff that you're in. When you start out with this, well, we'll be asking for your location, and like, well, you can provide it, and after that it will figure out where you are. I guess the antenna is somewhere over here, so then the location is here. As a placeholder, we're using just the same bike logo for now. And what we did was that we spent quite a long time just figuring out like how do we draw a circle that is like fits around the area where you can reach from wherever you are in a way. On top of this, we had this kind of filtering on what is like of this that we have the radius, and that is like all possible. But then again, there can be different ways of things. For example, if you're in here, it might not be that easy to get here than it is to just go a straight line over here, you know. So like this could be possible, like per average, but maybe not here, in a way. So that's where the route planner comes in, and like what we're doing is that we are actually like querying for the data available from the like stations, that like how long does it take there, and if the 30 minutes is like up in that estimation, then we would actually like remove it from the station. As another version, because we have 2 versions, otherwise probably could have been like deploying to some div leaflet or so. Same thing, it shows you the location when you get in there. Well, let's have the full demo here. So let's update, and it will ask you for the location, and we can see we are over here. So maybe so kind of the use case starts from here, that like, hey, we are here, and we might want to use this one. So then we can actually like get it to actually display the map of like, okay, these are available for you, and then you know like from here like. This is the starting point in a way. So now we were in the like middle of like we should combine these 2 informations of like this info that like we calculate the area of the around, and then just like is it actually even possible, and show it. And also displaying the data. Main takeaways for this. HSL is providing crazy amounts of open data to use for the users to develop things. That's one thing for sure. And also they have done a lot of things already in a way. Of course, regarding this kind of project in a way. And the other thing is simply that kind of rapid prototyping to React is kind of easy and easy to set up and get going with in a way. For the continuation, what should probably be done next? This is kind of this gets you kind of up and going of things. First of all, maybe one thing is that now we have a working template of how to work on with the map that is being provided by HSL, just as well as everybody else also as well. I don't know, I guess it could have been done in sections. As I noticed from the other teams also, everybody was probably struggling with these kind of things, how to display things in a way. Then the information stuff, because I totally forgot to explain on the show, sorry. Because our other problem here is that now this one is based on where are you located and what is your radius, so it's not that way relatable in a way. But with this one we were able to actually show information about we were able to see, whoops,
Okay, we should round it up.
Yeah, it's a demo effect, So anyway, well, it's very accurate. That's what I like the most about this. And what you can actually see is for example, this number of bikes, which is already provided by HSL.
It's real-time data.
It's also real time. And the point is that what the point here is that I lost my trail of thought. Is that we should probably also display it just like they're also displaying it. But then again, for example, what are the filtering options? What if we really, as I mentioned, want to just not display these at all? Maybe we could have because now we have this kind of full screen experience. It's not on middle of a page in a way. I'm not, point is not to mock or anything. It's just that this feels kind of small, and especially if you're on a phone, it can be super small to navigate in a way, what's actually in this. Well, now on a big screen, of course, you can see everything, but it's on your phone. It's kind of difficult. So, and what else did I wrote down? Sorry. this kind of free load presentation. Yeah, so that's pretty much kind of it in a way. And looking at the other teams also, I think you guys would be providing good stuff. I don't know if that could be actually used also as well in this kind of case, providing this kind of some sort of markers of is it decreasing or increasing the amounts or something like that, that maybe you shouldn't aim for some certain station, but that's kind of the point before you get the bike. Or what if the bike station is full? They have already solved this issue though, so that's something that we shouldn't be either worried about in a way. So I think that's our team. Thank you.
Thank you. Oh, it's super loud. So being the third team or the last team to present a solution, the previous team's tackled as well, is obviously not a glorious situation, but we'll try to cope with that. So, how many of you have ever walked to a city bike station only to realize the last bike is broken? Please raise your hand. I see quite many hands. And yeah, it's super disappointing. And we wanted to tackle this, or to prevent and mitigate those disappointments. Our solution is a real-time map that provides obviously the city bike station locations, numbers of available bikes, but also visualizes whether the station is about to run out of bikes or if the remaining bikes are most likely broken. And yeah, that obviously saves time and prevents those, I don't know, sad Monday mornings. So the key idea is to predict real time the number of bikes that should be available at the given station, and then in case the number of bikes fetched from the API is way more than what there should be, then we flag that station. And we'll discuss this thing a bit later, but the key challenge is that we don't know the true labels for those numbers. Then We also estimate the remaining time until 0 bikes, and obviously try to visualize everything so that you can just take a quick look to your mobile phone or a computer and then gather the information. Yeah, so we have these markers. We have those red labels for, or red borders for stations that are about to run off bikes, and then a tooltip showing the predicted amount of time left until it's empty. And the gray border is displayed for bike stations that most likely have only broken bikes left. Yeah. And yeah, it's live and running on bike.heroquab.com, at least for some hours today. And it uses currently the real-time data from HSL. Now that it's a Sunday and not super nice weather, I think there might not be any stations that are running out of bikes, but at least like 15 minutes ago there were bike stations with likely only broken bikes left. And yeah, please feel free to take a look. Okay, so the concept in a nutshell is to predict real time, as said, the number of bikes left that should be there, and we use the latest 30 minutes of known history. And currently, yeah, we're using just simple linear regression. Obviously, a data scientist could spend a day, a week, or a month tuning the forecasting model, and we didn't have that time. But this is a concept. Then we have some sort of logic to flag the stations with broken bikes. And quite often the pattern is such that those low spikes, negative bikes, or spikes are mornings. So we have minutes on the x-axis, and quite many stations have the pattern that the morning comes, the bikes go out, and then there's one bike left, or something like that. And yeah, again, we don't have the current labels. Some expert judgments or research papers assume the number of broken bikes in a city bike sharing system is usually some 1% to 5%, meaning with the 3,000 bikes and 300 stations in Helsinki, there is less than one broken bike per station at a given moment. And yeah, we don't have the correct labels. And first, this causes troubles to our prediction, like, yeah, we can't validate our model, and also the whole history is biased. So like 2017 time series for the whole summer is biased. There are obviously bikes available that shouldn't be there, and we just can't remove those from the time series. And thus we didn't pay them time to fit any more advanced model. Yeah, next steps could be tuning the model, incorporating history after cleaning it, tuning the UI, improving forecasting, I don't know, Facebook Prophet, as the Bayesian structural time series model could be a really transparent, fast, and accurate model. And the thing that the other teams were able to do would be nice also to predict the time until a new bike arrives. If the world was perfect, we would like to have the correct labels. Also, bike ID specific information would be nice. Then you could directly detect whether one bike has been laying there for days or hours. Yeah, that's about it. So our key ideas or key outcomes with our working product were truly valuable information for the customer or commuter, easily gatherable information, and then fast loading time. This works faster than the kaupunkifillari.fi made by Reactor. Thank you. Yeah, we have one question. Brike, brike.heroquab.com. Any other questions?
Can you display it? You have it there?
Yeah, sure. Oh yeah, here it is. And we can also show that if you move the cursor to the red station, it says it will most likely run out of bikes in 11 minutes. And we fetch the data every 30 seconds from the HSL API.
Question.
Yeah.
Did you go out and test it?
Yeah, actually, yesterday evening, when I went home, I took the only remaining bike from Narikkatori, and we had the gray label, and well, being a broken is actually not a binary thing. The gears didn't work, but I was able to ride the bike home, so I don't know. I would say it worked.
Yeah, so our presentation is a bit strange. Maybe it's directly from Sublime Text, but we'll have some 3D stuff actually. So we sat down. We had a team of 4. We are still 2 strong at this point, and we sat down and kind of thought that what are the basic problems with public transportation when you're on the field, kind of like going about and trying to find the real kind of landmarks or bus stops and other real world things where you hop on and hop off the transport. And we basically found that tram, train and subway are usually easier because there's less change in the station. So you can usually get to those, but the bus is sometimes especially difficult because the bus stops may be in quite obscure places. And for example, in Finland, when it's winter and you've been in a complete flow in the bus and you've been tuned on to listening to music or your favorite podcast or something, and then you jump out of the bus and you're like in middle of nowhere in the pitch dark. You're kind of like lost there. And so we took a look at the 2D maps, and we found out that they lack these visual cues to actually enable us to understand the bus stops. So we have to kind of do the brain lookup. We have to think 2D, then we have to translate the map into a kind of what we see around us and start to orient ourselves in the physical space. And it might sometimes be really cumbersome. And thus we came up with the idea that what if we could programmatically do the 3D rendering easily? Because HSL has data about their own bus stops. They have, as we saw, they have plenty of data. And OpenStreetMap has an API which is a huge swath of 2D data. And there's a plugin which is $5 or something. It's basically, it's open source. There's a donate $5, basically free code that can do a flat 2D map into 3D and a little bit of custom code. And you can render a 3D view of any bus stop wherever. So we can generate arbitrary high-res 3D images where bus stops are in the correct place in realistic projections. So it looks like a photograph almost. You can then add quality later on if you wish to use like real world like graphics, bitmaps and so on. But basically you get a quite good looking 3D image of the bus stop, and you can visualize it better that where should you go next. I can probably show it at this point. So this is a typical, this is not HSLs, but this is a typical way usually maps are projected. This is Google Maps, but they have this trouble that it looks a little bit different here. That, for example, this is the bus stop. It's there, and this is a real case of one of our team members who was trying to get about. He was trying to get about here, and he was left off there. And he had really big trouble kind of like going the last mile to the place where he wanted to go. And the 3D alternative would be something like this. It's a very short movie, but it's kind of like a drone. I should probably stop it like there. So it rises from the bus stop, and it shows the same scenario. This is very crude, but it shows the bus stop there, and then you can pan and zoom and do whatever you want, and you start to find the 3D buildings, and you can kind of compare it to your own field of vision. It's more kind of one-on-one of what we see in the world. Yeah, we also kind of like run a bit out of time there, but real world cases, we would estimate that you can solve this last mile problem of connecting basically bus stops, but also maybe these kind of elevated stations where the public transport is interfacing with complex buildings where it's not like flat 2D anymore. It's much more important to find a real place there, which can always be also quite obscure in 2D maps. So we would help HSL to kind of people would find security in using public transport, so they wouldn't be getting lost in these terminals and kind of psychologically feeling that they don't know or can't find the bus stop. That's an estimate, couple of weeks of dev time, mostly Python web. There would be a finished microservice which can render any bus stop in 3D. Yep. Thank you. Do you have any questions to ask? It's always nice to answer if there's something. This is really rudimentary, quick, and we didn't use much data. We actually used kind of like OpenStreetMap mostly, but I think there's a lot of also valuable data that can be used.
The movie you showed us, how was that generated?
Yeah, the movie was generated using Blender, which is a 3D software. So this is manually produced, but basically it's really easy to programmatically drive the same. So you kind of define the camera viewpoint, and the plugin makes these things. It visualizes the roads as 3D objects, and it automatically builds the buildings with their. There's a key called height in OpenStreetMap, so it adds the height to the buildings so they look approximately correct. This was just a manual rendering of a bus stop. So there can be a couple of models added there, so they more realistically kind of look like the real bus stops. That's just a very crude prototype. Do you have any other questions? Always welcome. Okay, thank you.
Hello everybody. So our project was the Know Your Neighborhood. So basically the idea was to show as much information for specified location as we basically can. Like when we, or like the, how to say it even. Like where I found the problem was when I started looking for my own new apartment. So okay, I started reviewing like maybe not hundreds, but at least like 20 different offers of the apartments. And the main problem was that for every apartment I had to copy paste the address, go to Google Maps, then start checking, okay, what shops are around, what parks are around, what schools, and etc. Like basically service by service I had to check everything. Then I had to go to the ratio pass and check, okay, how well is it connected? If I would like to have more information, probably I would need to check, well, pretty many other websites. So the idea was basically to create single application which could deliver all those information just by typing address of the location. Eventually by typing 2, and then we can of course know even more, like for example, how two places are connected. So in the project we had 2 teams. Unfortunately only one was able to deliver like something what is fully working and is presentable. However, I was very happy to observe the 2 different approaches which those teams decided to take, and it was very nice to observe like how they were really trying to solve this problem. But yes, let me give the microphone to the team 1, which
so we have a nice small React app where you can insert your starting point. For instance, if we look at Helsinki itself, then we will have as center, we will have the central railway station, and then we will find everything around that. So if we zoom here in, we have things like services like culture, daycare, traffic, health, education. We can see where the next bike station is and the distance in meters. So here's the center, so it's pretty near. The next terminal is 3 meters away, and we want to go here, and we have also the it's not shown here, but we have also the different itineraries to get there. Maybe I can show it. It's not shown. It's too small. Here you can see one of them. So you can go here in 7 minutes. You can walk, then use the tram, and then walk again, and then you're here from the train station. The rendering is not done yet properly, and yeah, that's the demo.
Yeah, so basically if you wanted to move there or somewhere else, you would see how close different services are, like how close the bike stop or the nearest public transport terminal is, and then the services like around the walking distance away. And there's an overview of the services, like what's nearby. And then, for example, if you want to see how you can get to work and how long it takes, you enter the work address and it shows you how to get there.
Where do you get that information from?
Next slide. Okay, so yeah, we can start with the route information.
Yeah, so those itineraries that you saw there came from the routing API. So if you're moving to a new town, you're probably interested in your commuting time, how you can actually get there, so what kind of modes of transport are there. So that was came from the HSL routing app. We had lots of different itineraries, and then we did some itinerary evaluation. So on duration, number of changes, how easy it would be for you to commute. And we also calculated the CO2 emissions, because some people might find that valuable for them making their decisions. And we also did some more evaluations as well, but we didn't actually put them into the app. But all of it is trying to make it easy for the user to make a decision on where they should move based on the times to different places. And then that was fed into the user interface.
So basically we started this work with by looking at different databases, what we have and what we can use. We found 2 databases that we use. The first one is the HSL Open Data. So in that open data, I think some teams used it as well. You can actually find the locations of transport terminals and city bikes, like coordinates and names. And then the other database we used was the Helsinki map service, something like kartat.helsinki.fi, and in there you can select what you want to see, like daycares and schools, and well, most of the information there was not really interesting, like it was like parking meters and stuff, so we had to filter most of the data out. But after that, we got a database of interesting, or hopefully, possibly interesting locations like the schools and libraries. And after we got the data, we worked on the Python code to kind of find the closest bus stops, terminals, and the bike stops you saw there. And then another one we did was to like, if the user selects a walking distance of 800 meters, then it shows on the map what kind of services there are. And yeah, do you want to?
Yeah, and finally we had to put that all together into one REST service. So yeah, I had to combine this all and write the REST API and send this properly to the front end. And yeah, this is what I did this morning. So it wasn't working until, I don't know, half an hour ago or so. Before that we didn't have anything running properly. But now, as you can see, it works. If I would have a little bit more time, I would have deployed it somewhere, because now we have everything there. And yeah, that's it. Do we want to search something?
Myyrmäki.
How is that written?
But it's not Helsinki, so I'm not sure if it's gonna.
Yeah, we might not have Vantaa, so maybe
Oh.
Helsinki locations.
Okay, sorry.
Yeah, it's already there. Let's see.
Let's say Katajanokka.
It takes us a second. So there are some ways to get here, and it takes half an hour, 20 minutes.
Question?
Yes, please.
Okay. It looks like you are kind of like combining different kinds of things, like where is the transportation, where are the connections to other things, and this is all for something that is some decision making on where you would be probably moving or what is the most nicest place. Did you actually think about this kind of like giving like some sort of score based on the services and lengths and so on?
I can answer. So yes, I can. Theoretically, there was idea. Yeah, I can actually maybe take the micro. Yes, so there was idea to make some scoring. However, the problem with scoring is that different people have different needs about the services.
Yeah.
So, for example, if we talk about like young family with baby, then probably more important will be that okay, there will be some schools, kindergartens, and etc. But if we talk about some single, then he will totally not care about schools, but he will need more like shops, bars, or something, for example.
And same thing if they were students and so on. Yes. So that's like one thing you could ask, like preferences of like, are you a student or do you have a family and so on. Because this sounds more like this sounds like actually a good like because I remember talking with you about this like possibility to have like where to fetch those services, and the problem was that like where to get like good enough kind of stuff.
Yes, there was actually the drop down on the beginning that you could select what kind of services you wanted, but for purpose to like be able to deliver it faster so that we will fit in time. I just dropped it and decided let's just display everything for now. But yes, that's for sure like one way of defining the need.
Because I don't know about the, like anything about the legalities or how it works, but this sounds like actually like some sort of like applicable product to like to actually market to people, that you could like rent the service to actually look for an apartment based on these statistics, and you could give like that this is the pricing and this is the price per score and so on, and I could see this like kind of happening and people using this some sort of like yeah. That's not for a while. But I'm just thinking about these kind of things, because these are always these things that you look into for a while and so on.
Any more questions? Who wants to use it? We are marketing it now.
Sign up to our waiting list.
So basically, the point of the project was to let you to travel around the world without leaving your coach. So you don't need to go to the bus station, you don't need to enter the bus, think where are you going and so on. You just can make your own virtual passenger and guide him around the world. Does it work? Yeah. So that's how it currently works. We didn't manage to finish it. But if the buses will be in the range of the passenger, you will be able to get into the bus and your virtual passenger will travel around Helsinki in the real bus. And that was the point of the project. And now we will present what is happening behind when we will have some...
I can't see what I'm doing, so I'm going to go off the screen. So we have this back end running, and we have a passenger. Actually, we have a whole bunch of different entities represented. So we got this passenger and a controller, and we're also subscribing to this HSL high frequency positioning app. So the passenger is basically us. Like you can see, there's me, and my position is right now in this office. And we can do, for example, we can, am I caps locked? Yeah, sorry. We can see what their nearby vehicles are near me. It's a bit difficult when I'm doing this, but yeah. So these are all the vehicles that are currently near to us. And we can see, for example, that there are many vehicles, like I think like 400 or whatever in the vehicle fleet. So that's just a subset, a small subset of what we see all around us. And if we grab one of these vehicles, let's say this bus here, we can actually enter it. Yes. So this is like a command line interface to what he just showed you. Yeah. Passenger, and I have to just sort of put that in manually. Hopefully it's not out of range by now. Okay, so we entered the vehicle, and if the vehicle is moving, we can see that our position is also updated. Is that the case? No, the vehicle's stationary right now. But maybe there's another nearby vehicle that is moving.
You have to choose wisely.
Yeah, exactly. So what we're going to do is something we can't do in real life. We can exit the vehicle, of course, but that's the boring way. We can teleport to a nearby vehicle, which is more exciting and interesting to us. So we're now in bus 5528. We're going to get a tram, maybe. Yeah, maybe that's a bit faster.
What about the congestion?
Okay, let's see if it's not out of range already. Okay, great. We entered it. So we managed to warp to it. Whoops. Yeah.
Whoops.
Just wanted to get my position. It's kind of hard to see when I can't see what's on my laptop. Yeah, so you can see it's updating our position, and the position of the vehicle is the same. So if we, for example, exit now the vehicle, which we can do by calling exit vehicle. And the reason I have to pass the passenger to it is because in the future we're planning on having multiple passengers moving around this HSL map, using the HSL system virtually, because that's more interesting than using it in real life, apparently, waiting for the bus. So we just exited, and we can see that our position is now stationary, like where we are right now. And if I look at this vehicle, it has moved on, probably, yeah. It's at a different position than we are right now. So we have successfully exited the vehicle. So what have we learned today? We can teleport between vehicles and exit them. And sorry for the complications. It's kind of difficult to when you can't see what you're doing. And yeah, we have. So this back-end model is running. It's just a matter of getting the front end figured out.
Small fixes to handle the events correctly and
yeah. So I think
the red guy to move around the map.
And yeah, our team name is Team GIMP. It's our.
True, I forgot to introduce. Yeah.
Those are our initials, essentially. Are there any questions? And thank you for your attention. Hope that was clear.
Are you trying to like build a game or something?
I'll let our team lead field that question.
Yeah, that was basically the point. Yeah. Or simulation of real life. Yes.
I was actually wondering, like, currently, if it is possible to leave the bus when the bus is.
Yeah, in current implementation, you can leave the bus in the middle of road on the middle of track. Yeah, that's.
That is not safe, you know that.
Yeah, but our virtual passenger doesn't care about that.
Did you try the multiple passengers at the same time as well?
We barely implemented one.
scenarios, rush time.
Yep, that was one of our tracks that we were trying to achieve. But the first step was to at least simulate one passenger, and then unfortunately we had quite small resources to handle the big simulation case.
Yeah, did you basically get like peak hour estimates and all this?
Yeah, we can estimate, assign some guides for every single passenger according, for example, for the routing API of the HSL, and then we can simulate how they will split over the map when going the routes, and also we can limit the possible vehicle capacity. So no every passenger can enter the full vehicle, and simulate tram congestion, for example.
One last idea related to that was also simulating failures occurring, not so much like just minor bike failures or disruptions, but failures at major nodes in the network or major edges, like I don't know, track failures or blocking, let's say, a highway or something. Like if the ring 3 or ring 1 gets blocked, so that'd be interesting to see.
Hello, everybody. Are you ready to hear the winner? Yes. I'm not going to tell. I have somebody else with the prizes. It's Jarmo from Lamia. Here are the results. Welcome to the stage, Jarmo.
The winner is... Can everyone make drums? Congratulations, guys. Congrats. Maybe if I ask a few questions. So you're the team of 4 people. Have you participated in this kind of events before?
Actually, this was my first hackathon this far.
And
I think we have participated quite a few times. And how were you? Twice before.
And did you enjoy our hackathon?
Yeah, it was nice.
Was like the best hackathon you have ever been?
Well, one thing I enjoyed a lot was that like projects were done for something that hopefully serves the public good instead of like some multinational corporates.
Excellent answer. Thank you. Do you have anything to add?
I really think the food was really good. So much better than pizza.
Anything else you want to say?
Like it was actually nice to work here, and we didn't push that hard into the through the night, and it was different but quite nice.
Okay.
Thank you.
Nice office.
Oh, thank you, thank you. We have heard that a lot. And so I don't know you guys before. Maybe you're not from the WWF, but maybe Aalto University.
Yeah.
Okay, you're students.
Yes.
Okay, excellent. So I will not ask any more questions. I will give you some rewards. So, winner team gets this kind of verkkokauppa.com lahjakortti.
Gift card.
Gift card, yes, that was so. Here's for you. For you, congrats. For you, and for you. And can I ask your names, actually?
Yeah. So I'm Henrik.
I'm Ilmari.
Jonathan.
Jonas.
Okay. Thank you so much. Thank you for everyone. Let's give the applause to the winning team.